Hi guys. So by the end of the video, you guys are gonna know, or hopefully know, how to find area of a regular polygon. So if you don't remember what a regular polygon is, a regular polygon has all sides that are congruent and all angles that are congruent. But before we get into that, there's a couple of things we gotta point out. There's new vocabulary that we're gonna talk about that you've seen before, but we just call it something different. So when we're talking about regular polygons, we have what we call an apothem. It's apothem, okay? And it's usually denoted with a little lowercase a. And so what the apothem does, or what the apothem is, it's going to start at the center of your regular polygon, and it's going to go perpendicular to a side. So if this is the center of my polygon, it's going to go perpendicular to the side. Now remember, perpendicular means creates a 90-degree angle. And so here, this is what we call the apothem. And as you can see, you have the number of apothems that you have is the same as the number of sides that you have, because we can draw the apothem to each side. So we can draw apothem there, apothem there, apothem there, so on and so forth. So really, the number of apothems that you have is equal to the number of sides that you have. And the only thing you have to remember is that they are going to be perpendicular to a side. Okay. So if I ask you to find the area of this polygon, we can try to break it up into smaller pieces, or we can also figure out or notice that we have multiple triangles here. So if you notice here, we have a triangle, and then we have another triangle, another triangle, and another triangle. Now I know that's kind of hard to see, so I'm going to erase some of these lines. So I'm going to erase some of these apothems, and we're only going to focus on one particular triangle. Okay, so let's go back to me saying that this is a regular polygon. The reason it's a regular polygon, or the reason that they have all congruent sides, all congruent angles, is if we were to put a circle around this pentagon, tell me what you notice about the sides of the triangles. Now, don't get mad at me because I know it's not a perfect circle. I tried. But what do you notice about this blue line right here? In other words, what does this blue line represent? I agree, it's the radius. And so because that's the radius and that's the radius, they're not changing, which is telling me that the distance of these two legs of the triangle are congruent. And so if you notice that since they're all congruent, we know that all 5 of these triangles are exactly the same. And so if they're exactly the same, really all we got to do is find the area of one triangle and add it 5 times, or a faster way would be just multiply by 5. And so before we continue, remember, for area of a triangle is just 1/2 base times height. Now for our purposes, the base of my triangle is down here. Now instead of calling it B for base, I'm going to call it S for side. And so that S represents the side of the triangle, or really the side of the polygon. And so what I'm going to do now is I'm going to replace these the base and the height with what I labeled on the diagram. And so I'm going to rewrite it one more time. So I have area, and then remember, this is area of the triangle. Area of the triangle is equal to 1/2 the base, which is what we're calling S for side, and H is A for the apothem. And so that's going to give me the area of just one triangle. And if I wanted to find the area for all the other ones, remember, because they are all the same, I simply multiply by the number of triangles that I have, which in this case it's 5. But if you think back when we were talking about angles. We used a special letter to represent the number of sides that we had. And that's always changing. For example, if we had a hexagon, then instead of 5 it would be 6, or we had a pentagon, instead of 6 it would be 7, so on and so forth. So if we're trying to find a general form or a general formula, that letter that we use to represent the number of sides is what we used to call n. Now, it might be a little hard to see, but all these three things here, when we multiply now, it's not only going to give us the area of one triangle, it's giving us the area of the entire polygon together and the entire shape. And if you notice, when we multiply s and n, or side times the number of sides, what is that actually giving us? Well, if you think about it, s represents the side length of my triangle, and n represents the number of sides. So if I multiply s times the number of sides, it kind of outlines the shape of my pentagon or regular polygon. And so really it's giving me this dimension. And when we get the outline, I guess you can call it, of the polygon, it's really giving us the perimeter. And so we're going to make one more change to our formula, and that's going to be our final change that we get for finding area of a regular polygon. So instead, we can write it one of two ways, but the way you're going to see it the most is as follows. So instead of writing side times apothem times number of sides, we're going to replace that with we're going to leave the apothem, and instead of using s and n, we're going to say p for perimeter. And so we're going to define a little bit of things here. A, remember, that represents your apothem, and p here represents your perimeter. Now this only works if you have a regular polygon. And so before we move on, there's one more thing we got to talk about, and that is what we call central angle. And how do you find a central angle? So remember, your central angle, first of all, is located inside in here at the center. Okay, so in other words, how do we find what the measure of one of those are? So one thing we want to remember is a full circle is 360 degrees. And since we know that all of these 5 angles are going to be exactly the same, we're going to divide that by n, or the number of sides that we have. And so here we have a formula to find central angle, where n is number of sides. And so you're probably wondering, why do I need to know the central angle for? Well, you're not always going to be given the apothem. And so we're going to have to, at some point, be able to calculate the apothem. So the way we calculate the apothem is, one, we find the central angle first, which is the green one. And after that, because these two sides are congruent, then we know that this angle here is going to be half of your central angle. And so, quick example, if we're trying to find the central angle for this pentagon, we're going to do 360 divided by 5, or 360, which is the full circle, and 5, which is the number of sides or triangles that we have. And that gives us to each central angle to be 72. And so simply, this central angle, the big central angle, is 72. And to find the smaller angle, we just take half of it, which in this case it's 32. So we're going to attempt to try to do our first problem together. And this is one of the harder problems because they don't give us our apothem, so we're going to have to find it. So the first thing I'm going to start with is writing the area formula for a regular polygon, which is 1/2 apothem times perimeter. And on the side, I'm going to put what I have and what I don't have. So if you read the problem, they're telling you that the perimeter is 60. So we know P is 60 inches. And Apothem, we do not know, so that's our goal. So the perimeter is 60 inches, which is telling us that because we know it's a regular polygon or a regular hexagon, each of these sides is exactly the same. And so if we take our 60 for perimeter and if we divide by the number of sides, which in this case is 6, is telling us that each side length is 10. So that's 10, so on and so forth. So the next thing we got to do is we got to figure out the Apothem. And in order for us to figure out the Apothem, we first have to figure out what is a measure of my central angle. So remember, central angle, we're going to take 360, which is the entire circle, and we're going to divide by the number of sides or the number of triangles. And here we have 6, which tells me that each central angle measures exactly 60 degrees. And so we're going to take it a little further. So remember, Apothem is going to be perpendicular to the side and is going to bisect the side, is going to bisect the angle. So really here, my angle that I need for this particular triangle is not 60, but it's actually 30. Okay? And if you remember, now, because this is 90 degrees, now we have a 30, 60, 90, or a special right triangle. Across 30 is always going to be x. Across 60, which is here, is always going to be x square roots of 3. And yes, I know it's bringing a lot back, but we're going to make it work. So let's go back to the side. The side measures 10. And if we bisect it, that means each one of these is 5 and 5, which is good because I have information for this side which is telling me that my Apothem is actually 5 square roots of 3. And really, I have everything that I need to finish finding the area of my regular polygon. So now that I found the Apothem is 5 square roots of 3, all I gotta do is plug it into my calculator. So I have area is equal to 1/2 the Apothem, which we just found to be 5 square roots of 3, and the perimeter was 60. And so I can put that exactly how I see it into a calculator, and I get a total area of 259.81, and can't forget about units, inches squared.